All right, everybody. Welcome to our November Akka.net community stand-up. I'm joined here by Gregorius today, and this.
Good.
Hey, Gregorius, how you doing?
Oh, pretty good.
Pretty good. Gregorius and I were just going over some perf view data while we were waiting for the for the session to start. Now, one bit of bad news: our show and tell speaker, Priva, one of the speakers was not able to make it short notice today, so we're probably going to postpone their talk until December or January. Unfortunately, speaker had a pressing real life commitment that came up all at once. Sick kid. So you know how it goes. Real life sometimes does not comport with our open source and extracurricular sort of activities sometimes. So that's no problem. We'll catch them next month or maybe in January. So this community stand up will probably be a little bit shorter than usual as a result of that. That being said, I do want to go ahead and get into our recent Akka.net releases. Now, we had our October community stand up kind of late last month, and we had this one early, so we don't have quite as big of a window for releases as we normally do. That being said, we have still released some new stuff. Namely, let's start with Akka Management 0.30 Beta 3. So, Gregorius, what's the deal with this release?
It's basically just a minor quality of life improvement for Azure lease. Before, we didn't actually show any error messages when user forgot to set the service endpoint in their setup class. Now it will just complain that you haven't set this and the Azure credential won't be used.
So we're in the process right now of actually working with a couple of different users who are using the Azure Blob storage lease to do split brain resolution in Akka.net. And that's where we've been getting some of this feedback from. This is all kind of part of our standard process for taking things that have never been used before and getting them out of beta. We typically like to get typically it's Petabridge support customers are usually the ones that we work with. But we like to get them to start using some of the basically betas of these packages first, make sure things work as expected, get real time feedback from them when they don't, and fix them. And then after we've gone through a few iterations of that, we typically will publish these. So Akka management and both Akka hosting are getting pretty close, I think, to being able to take completely out of beta, which means that we're going to freeze the APIs at that point. Speaking of which, in terms of other releases, I have the Akka.net 1.4.45 release. So this one reverts a breaking change that crept into Akka.net 1.444. This unfortunately caused some binary compatibility problems for a whole bunch of different Akka.net plugins. So we released this not long after we shipped 1.44, and we've since updated Alpaca, Akka Hosting, Akka Streams.Kafka, Akka Management, Petabridge.Command, all to go ahead and use the newest version of this. The only libraries I don't think we've updated are some of the plugins that weren't really affected by this. Phobos is actually a good example of that doesn't really have a problem with 1.445. And then there's a couple of other ones that some of the logging libraries that aren't really affected by this much either. So that's something that you should go ahead and keep an eye out for. And now, as far as future Akka.net plans go, what exactly have we been up to? In fact, I got to get here we go, my next banner up. What have we been cooking since our last community stand up? So, Gregorius, I'm going to go ahead and turn the mic over to you for a second. We can talk a bit about what we're trying to accomplish with Akka.Persistence.link to DB.
Yeah, Akka.Persistence linked to DB is our attempt to basically unite all of Akka.Persistence SQL into a single plugin. This will actually replace Akka.Persistence SQL.common that we use right now as a base for all of our SQL persistence plugins. Mm, Right now, we're still trying to basically iron out all of the kinks and make it production worthy. Uh, Basically, we're trying our best right now to make sure that Link to DB is compatible with all of the other existing SQL based persistence plugin.
So, for instance, one of the other projects that Gregorius has been very diligently working on is this Akka.Persistence.SQL exporter. This is a backwards compatibility test suite, is what this is, which basically takes data that is written using the most recent Akka.Persistence, MySQL, Postgres, SQLite, and SQL Server plugins. Exports. So basically, we have a set of actors that all do the same thing. Just the only differences between them are these plugins. We use this to populate a test database. We export that database into a SQL export file of some type. It depends very much on the underlying database server that we're using. And then we create a Docker image that mounts that backup and restores all that data for the purposes of doing backwards compatibility testing. Um, One of the things philosophically that we believe in really strongly in the Akka.net project is providing upgrade paths that are explicit and well tested for users. We are so keen on this because we believe that what a lot of open source lacks is really that degree of sort of professional care and attention to detail as far as being able to introduce impactful changes in a manner that is safe and doesn't force the complexity onto the end user. So this is an example of us doing that, which is we're about to rewrite the core of how a lot of these persistence plugins works, and we're doing that for three big reasons. The first reason is that a lot of these plugins kind of do their own thing in terms of how the schema is managed, how things are serialized, how queries are implemented. And that causes some pretty big disparities in terms of the quality of experience users have. And that makes sense. All these plugins were kind of originally developed by members of the Akka.NET community, with the exception of the SQL Server and SQLite plugins, which were developed by the core team. So you should expect a degree of variance there. We kind of want to smooth that out though, and provide users with a consistent experience. The second big thing we want to do is these plugins today, including SQLite and SQL Server, are very inefficient in how they do what's called tagged queries. Tagging is a thing you can do in Akka.Persistence that essentially offers you a secondary way of indexing events. This is very useful if you're building like a CQRS style application on top of Akka.Persistence. It allows you to use tag queries and Akka.Persistence query to do projections. I just finished writing for a customer in a consulting project we did here at Petabridge, a fairly heavy duty CQRS system that uses Akka.Persistence.Postgres under the covers to do all sorts of different reports that are all using essentially a set of original events and a bunch of different materialized views that support different reporting requirements this company has. Uh, Link to DB should give us the ability to remove the inefficiency that's in these plugins today, which is that we have to do a full table scan anytime we do a tag query from the get go, and that's because of the way tags are stored as these sort of semicolon delimited fields on your original events, which was a not a good design choice from the get go. But unfortunately, we've got customers that have many years of data that were stored that way, so we have to have a safe mechanism for moving those tags into their own table and indexing them so the query can be fast. And we have to have a safe way that's going to not destroy user data for being able to perform that migration. So one of the purposes of Gregorius's work here is to give us a test bed for being able to validate that those migrations are safe, that they are reentrant. So in the event that you need to run the migration more than once, maybe because you have to do a rollback or something else, we can make that done safely. And then on top of that, we need to make sure that the plugin for actually recovering data for your actors is also done safely. So we go ahead and continue to recover data and persist data in a manner that's consistent with what we did before. So this is not sexy work. This is not an exciting new thing you're going to see in a blog post and get super duper excited about. But it's important work, and it's the sort of thing that gets taken for granted a lot. But it's very crucial that we pay a lot of close attention to the details on this and offer users a safe upgrade path. And one of the things that we will start pushing a lot more once Akka.NET 1.5 ships are CQRS style recipes and patterns using Akka.Persistence query. Other persistence plugins like Akka.Persistence.Azure actually really have good support for tags out of the box today. And the way they do that is through denormalization. They just duplicate the event. There's a price to be paid for that, which is that when you delete an event, it doesn't necessarily delete the tagged incarnation of it. So there are some trade-offs there, but some of our NoSQL plugins actually handle this pretty well today. It's the SQL ones that are kind of lagging behind. So we're working on fixing that and paying off all that technical debt in the process here. So that's one really big change. So Gregorius has been basically working on consuming the output from this project inside Link2DB. We have a whole different configuration matrix for replacing all of these four original plugins here. And so far, it sounds like all those tests are passing. Is that right, Gregorius?
Yep, that
Okay,
is
good.
correct.
So basically, we've been able to validate that data that was written using an old plugin can be safely read and recovered using Akka.Persistence.Link to DB. Um, and that was and that the basically the original plugin as it currently stands right now for Link to DB kind of passed all those tests anyway. So that's something that's been going on there. Now, in terms of other future projects, I'll mention two that I'm working on right now. I mentioned very briefly when I talked about the delay in shipping Akka.NET 1.5 last month that I'm working on a new project for Petabridge. I'm still in the process of working on that right now. If you follow me on Twitter, you may have noticed that I've been tweeting about Blazor and that sort of stuff a lot. We're building a new product called Akka.NET Ops Center, which is going to give you the ability to manage and visualize your clusters. Basically, you can kind of think of it as somewhat analogous to Phobos. It's not going to give you super detailed actor traces and metrics like how Phobos does, but it will give you that sort of cluster overview that Phobos does. And we're going to have this available there's going to be a free tier, which anyone can sign up for. You can activate as many free clusters as you want. There's also going to be a paid tier, which will include some features that are more applicable for production environments, such as alert rules, being able to automatically invoke petabridge.command functions when certain things happen inside your cluster, all sorts of neat stuff like that. So that's what I'm currently working on right now. I've got I'll talk more about it once I've got something that's a little bit more complete. Developers tend to take things somewhat literally, so I don't want to show a half-baked UI and everyone think, "Wow, that kind of sucks." um, so I'm in the process of working on getting that up and running right now. That's one project I'm working on. The other one I'm working on, and I'm doing this in concert with the actual core CLR team at Microsoft, is trying to get to the bottom of this issue, which has been around for about a year now. This .NET 6 performance regression. This is an issue that has been reproducible from day one once we started adding dual targeting support in our benchmarks for .NET 6, which is that when on .NET Core 3.1, our performance numbers are pretty consistent after we get this is our remote ping pong benchmark, by the way. This is the primary benchmark we use for measuring Akka.Remote's performance across a single connection. Is what this is for. So this message throughput is basically keeping track of the number of messages per second that are going across that connection in both directions, by the way. So it's duplex. And this is useful for trying to gauge what the round trip latency is going to look like and what the maximum throughput is going to look like inside that system. We've had this benchmark for many years, 7 or 8 years now. So it's kind of our standard for that. You'll notice in .NET 6, the performance numbers were quite a bit higher. And this is our original benchmark from years ago. Were quite a bit higher than they were for .NET Core 3.1 initially, but you see this big sustained drop in performance here. Well, I originally closed this issue. I'm scrolling down here. I originally closed this issue some time ago with basically the assertion that it looks like this is something that only happens when we're running our benchmark because we're applying so much pressure to the .NET thread pool so quickly, and that a real application probably wouldn't run into this. And both myself and many of our users who are concerned about Akka.NET's performance were satisfied by that answer for a little while. But fast forward to maybe a couple months ago, some of our customers in spaces like high frequency trading started noticing that without changing the version of Akka.NET or changing any of their own code, When they upgraded from .NET Core 3.1 to .NET 6, some operations that used to take 2 milliseconds were now taking 10. And that order of magnitude difference is a massive problem for them business wise. That's the difference between their algorithmic trading being profitable and it being potentially unprofitable or high risk. They didn't tell me that. I'm just assuming that's what could happen. So I engaged with Rich Lander and a couple members from the .NET Core CLR team via email, and I've been running a whole bunch of perf view sort of reports on our remote ping pong benchmark. I'll go ahead and pull those up real quick, since this is what Gregorius and I were discussing right before our meeting today. On the left, I've got my .NET Core 3.1 numbers and my .NET 6 numbers. We have long suspected the drop in performance here has been related to changes that were made to the .NET 6 thread pool. They basically replaced the entire thread pool implementation between .NET 5 and .NET 6. In .NET 6, the thread pool is now fully managed. On top of that, they also will inject threads much more liberally than they used to when they think there's a sync over async happening, meaning someone's calling like task.wait or task.result inside a thread. So we suspected that setting was potentially causing some issues. The other thing that we observed is that Gen 0 garbage collection is significantly more expensive than it was in .NET Core 3.1. In fact, the .NET 6 benchmark spends about twice as much cumulative time in garbage collection than .NET Core 3.1 did, and that's all Gen 0. The Gen 2 and Gen 1 garbage collection numbers are actually better in .NET 6 than they are in .NET Core 3.1. So Gen 0, if you saw my presentation last week, is supposed to be the cheapest form of garbage collection. Yet somehow, even with fewer collections, we're spending twice as much time doing it. In fact, maybe I should open those numbers up real quick. I've got too many perf view tabs here. Let me go ahead and open. If I go to my folder here, let's go file, go to directory. Actually, I guess I needed to step up and go to /GC. I'll open my Perfview 6 numbers. Okay. If I go ahead and I take a look at our GC stats, pull this up real quickly. Remote ping pong is the number we want to pay attention to. And if we take a look at the table, we can see the total amount of, let's see, is this .NET 6? Total amount of time spent in garbage collection pauses, roughly 15 and a half seconds is what that looks like. And we get a breakdown of what that looks like by generation. Let's see. Where's that table exactly? Gen 0 pause millisecond time. And is this all? Well, actually, that's not really even the table I wanted to look at. GC roll up by generation. Well, I'll take a look at this. This is the average amount of pause time, and I believe this is measured in milliseconds. So that's .NET 6. Let's go ahead and compare that to .NET Core 3.1, which is right here. And we'll pull up remote ping pong. Now let's compare these two numbers side by side. First thing we notice, total GC pause for .NET 6, roughly 15 and a half milliseconds. Total GC pause for .NET Core 3.1, 8.6 seconds. So .NET Core 3.1 has slightly less than, it's not quite half, but just about half the total amount of garbage collection pause time that .NET 6 does. And so what's the difference maker here? We can see the GC pause times are lower on average for .NET 6 for the highest generations, Gen 1 and Gen 2, than they are for .NET Core 3.1. .NET Core 3.1, it's more expensive for them. But the big difference here is that 7.1 milliseconds is the mean pause time for Gen 0, whereas for Gen 0 on .NET Core 3.1, it's 3.9 milliseconds. Again, roughly half the amount of time spent. And I've got some other tables that I produced when I was analyzing this data, sort of long form for the .NET team. But basically, the total number of allocations for for Gen 1, Gen 2, and Gen 0 are all lower in .NET 6, yet the pause times are higher for Gen 0. So there were some pretty significant GC changes that were introduced in .NET 6. And by the way, those are still probably effective in .NET 7 as well. I haven't gone through all the release notes for .NET 7 yet, so I can't really offer any opinions just yet on what the impact of that'll look like. Maybe I'll go ahead and rerun these benchmarks using those numbers as well and see what we can come up with. But the long and the short of it looks like there was a combination of the interaction between the new .NET Thread pool and the new GC changes that resulted in a big increase in the amount of time spent waiting in Gen 0. Um, don't know why that is. The .NET team is looking into it too. Hopefully, we'll get some answers for you, and maybe even a patch that might have to go into .NET 8 if there is a regression that's been detected in the CLR, or they might tell us there's something funky with Akka.NET that we need to fix, which would probably be somewhere in our remoting stack if I had to guess. So we'll get to the bottom of that, but that's something that I've been investigating. I'll be producing a YouTube video talking about how to use perf view to generate these types of numbers for your own application if you're interested. It's actually not terribly difficult to do. The hardest part about this is actually interpreting what the numbers mean. That's more difficult than getting them. So, we don't have our show and tell today, so I guess we'll go ahead and end our meeting a little bit early. Thank you again very much for your time. We always appreciate it. And yeah, don't forget to like and subscribe. And we will see you next month. Right now, we currently have a developer scheduled to share his F sharp wrapper on top of Akka.net for December. We might have the Prevo folks present depending on what both the speakers want to do. But either way, we're going to have a speaker for both December and January. And we're going to still in the hunt for some show and tell speakers for February and March of next year as well. So if you're interested in sharing your company's story about Akka.net and how it's helped them and what some of the challenges you've had with it are, please don't forget to click on the show and tell application link, which we include in the description of the YouTube video, and let us know if you've been interested in presenting. So thank you very much for your time, and we'll catch you next month. And in the meantime, in the Akka.net Discord. Thank you very much.